previous classes. Today we are going to start another most important topic of the chapter ray optics, that is refraction of light. Refraction of light. Refraction of light. In class 10 you have got a little idea about refraction of light and also about reflection of light. We have also discussed about reflection of light in the beginning of this particular chapter. So what we found in case of reflection, that a ray coming from a particular source, after striking to a surface, it bounces back. But in the case of refraction, it is something different. In the case of refraction, light travels from one transparent medium to another transparent medium. Remember, light travels from one transparent medium to another transparent medium. And when light travels from one transparent medium to another transparent medium, the ray of light get bent. Okay? When it enters from one medium to another medium, in the next medium where it enters, then the ray of light get bent, and there are some change of velocity, there are some change of your wavelength, all these things each takes place. So if I show by diagram, it will be like that. If I consider here two transparent medium, suppose this is the interface of two transparent medium. Interface means it is a surface who lies between the two medium. If I consider this is an air medium, this is air medium, and this is water medium. That means if I consider that light is traveling from air medium to water medium, like that, direction of the light from air to water medium. So in this case, what will happen? If you consider one situation, if this particular light travels from air to air medium, then there will be no change. That means it would have gone this way. This would have been its direction when the ray of light is traveling from air to air. That means in the same medium there is no bending of ray of light. Okay. Now as this ray is traveling from air to water, that means it is changing its medium. Air is another medium, water is another medium. So if I draw here in normal, then I can show you the direction of ray of light in the water medium. It is, you can observe from here that it is bending towards the normal instead of going this way. So this will be your angle of incidence, this will be angle of refraction. If I give some name over it, this is your A, this is point B, this is point suppose C, and this is your D dash. That means we have found AB as incident ray, BC as refracted ray, D dash as the normal. Okay, in this case, what is happening now? This ray of light is coming from one transparent medium, and when it enters to another transparent medium, it has got slightly bent. Bending means either it will come towards the normal or it will go away from the normal. So when this ray comes towards the normal and when this ray goes away from the normal, it depends upon from which medium to which medium ray of light is actually traveling. In this case, we'll have concept of two things: the rare medium and denser medium. Okay, rare medium and denser medium. Let me tell about you what is rare medium, what is denser. Before that, I am telling you one thing. You have found refractive index. You have got one thing. This is refractive index. Refractive index is expressed as mu, that is equal to what? C by P. Refractive index is expressed as C by V, that is speed of light in vacuum. Speed of light in vacuum, the ratio between speed of light in vacuum and speed of light in that particular medium, that is called refractive index. What refractive index? Speed of light in vacuum and ratio between the speed of light in vacuum and the speed of light in that particular medium. Okay, ratio of speed of light in vacuum and speed of light in that particular medium will be known as refractive index, that is expressed as mu. Now what I am telling these things, as I told you, if I consider that air is your rarer medium and air is rarer in comparison to water, so water will be denser medium in comparison to air medium. So in case of rarer medium, this mu is minimum. Refractive index is minimum in case if it is in rarer medium. Refractive index is higher, or refractive index is maximum in the denser medium. Okay. Now as you can see, when light is traveling from rarer to denser, how can you say this? We know by practical experiences, or by the, if you calculate the mu of air and water, you will find who is denser and who is rarer. There is a particular chart, and where you can find the refractive index of water, air, glass, of all these things. Now in this case, if I consider that air is traveling, light is traveling from rarer to denser. So once light travels from rarer to denser medium, then what happens? The refracted ray bends towards the normal. That means I can write that here it is bends towards normal. When it bends towards normal, as you can see that light is traveling from rarer to denser medium. Okay, light is traveling from rarer to denser medium. Next, if I consider another situation, if I take one more interfaces like that, so this is an interface, and if I consider this is your water medium. What is this water medium? Water medium definitely will be denser. If I consider here this is air medium, so air will be your rarer in comparison to water. So if I consider that the ray is coming from water to, this would have been its origin direction if it is traveling from water to water, but it is coming from water to air, that means there will be change of speed and change of direction. So if I give a normal over here, this is normal, so what will happen? This ray will be going away from the normal. Remember, very important point, this is your angle of incidence, this is your angle of refraction. Understand? So this will be the direction. So in this case, what happened? The refracted ray goes away from normal. When it goes away from normal, once it travels from denser to rarer. So very important point. Once it travels from rarer to denser, as of now, air to water, then the refracted ray bends towards the normal. Remember. Secondly, if it travels from, it is denser to rarer, then it will happen. What will happen? The refracted ray will go away from the normal. That is very important to point. Now in this case, one more thing will come. In case of reflection of light, we have studied about angle of deviation. Angle of deviation in this case, in case of this particular diagram, this will be the angle of deviation. That is delta, angle of deviation. Understood now? Angle of deviation, how much it deviates from the origin path. In case of this was its origin direction or not. Okay, this was its origin direction. It is bent this much, so this is going to be your angle of deviation. Understand or not? This was its origin direction, and how much it has deviated from origin direction, this much, so this will be angle of deviation. And in this case, how much it has deviated from angle of origin direction? This much. This will be your angle of deviation. So angle of deviation in the first case I can calculate as delta is equal to angle I minus angle R. In case of first angle, because incident angle is greater than refraction angle, I can write down since angle I is greater than angle R. Is that clear to all of you? In the second case, the angle of deviation I can write as angle of R minus angle of I, since angle R is greater than angle I. In the first case, incidence angle is bigger than refraction angle, and the second case, refracted angle is bigger than incident angle. So that is how we can find out the angle of deviation. I hope you have understood it. Very simple thing, and very simple topic of refraction, but very important in the case of concept of reflection of light. Now, as you studied, we have got two laws of reflection of light in the previous reflection topic. Similarly, in case of refraction also there are two laws. What are these two laws? We will study now. You first of all note it down. So if I consider, or if I study about the two laws of refraction, you write down laws of refraction. Very first law will be number one. I can tell you this is AB. AB is your incident ray, that is your BC. BC is your refracted ray. D dash. That means incident ray, refracted ray, and a normal lies in the same surface. Second thing, as you can see, this angle I and this angle R was equal in case of reflection, but in case of refraction they are not going to be equal. You cannot say they are directly equal. There is a formula about it, that is sine of angle I and sine of angle R will be always constant. Very important thing, remember. In case of refraction, the relation between angle of incidence and angle of refraction is stated like that, that sine of angle I and sine of angle R will be always constant. This can also be known, this is also known as Snell's law. This is also known as Snell's law, but Snell's law can be written, we'll explain about Snell's law after this classes only. So this is your these are two laws of refraction, and this is also known as Snell's law. So what is Snell's law? That sine of angle I and sine of angle R, the ratio is always constant. This constant is relative. This constant is relative refractive index, important. Okay, ratio of sine of I and sine of R is a constant, and this constant is generally relative refractive index. In case of refractive index, you will get two type of index. That is, one is absolute refractive index. Absolute refractive index is with respect to vacuum, and your relative refractive index with respect to there are two medium. That means if I consider, I'll show you later on about this. What is relative refractive index? In this case, I can tell you. See here, this is your air, this is your water. So if I find out the refractive index of water with respect to air, that is mu of water with respect to air, that is your relative refractive index. Understand? But if you simply found that if you only write this is mu of water, then if you give this is, if you consider with vacuum, then it will be what? Refractive index, absolute refractive index of water. Absolute refractive index of water. This will be relative refractive index of water. Okay? Or you can say the refractive index of water with respect to air. These things is clear to you. So you mind it, the absolute refractive index and relative refractive index is not quite similar. So in this case, one thing I can say, what does actually sine I sine R means? So if I case two situations, if I have two situations, so what if I consider sine of angle I1 in case of first situation and sine of angle R2 will be equal to what? If you take one more situation, that is sine of angle I2 and sine of angle R3. If you take like that, so many angle. If I take here the sine of angle I3 and sine of angle R3, their ratio will be always constant, remember. The ratio will be constant. When if you take like 1, 2, 3, I1, I2 up to I100, all the ratio will become your constant. If you take first condition, that is I1, R2, again if you take next condition, I2, R2, if you take next condition, I3, R3, their all ratio will become a constant. That means I can write here mu sine theta is constant or not. Mu sine theta I can write as constant. Then what will happen if you see in this case what happens? If I consider the refractive index is mu1 in this case and refractive index is mu2 in the water medium. So I can write mu1 sine of I or not. Mu1 sine of I is equal to mu2 sine of angle R. So if I take the ratio out here, so this will be sine of I by sine of R is equal to, there will be angle, this is your mu2 by mu1 or not. If I rewrite these things, and what does mu2 mu1 means? In this case, one thing you have to see that in this case light is traveling from first medium to second medium. That means we considered here refractive index mu1 and here we consider refractive index mu2. So this will be refractive index of second medium with respect to refractive index of first medium. This can be also written as mu2 of 1. That means refractive index of second medium with respect to one medium. Understand now? So this is, you can write, these are the Snells law, you can write like that also. Understand? Or you can write this one also. These are the Snells law. You can write any one of it. I am just giving the concept of it. This is the Snells law. Understand? So let me come back to this point. As I have written here, what I have written here, that I told you it is mu2 by mu1 can be written as 1 mu2. Understand? If I write another thing, that is your, suppose mu2 by mu1, this can be written as, this is mu2 by mu1, sorry, mu1 by mu2. If I write here mu1 by mu2, this will be written as what? 2 mu1. That means refractive index of first medium with respect to second medium. These are the relations you can write. Refractive index of second medium with respect to refractive index of first medium. So if you see, this is air and water. So if I have told you this is how we should write about the refractive index. I hope you have understood it. It's a very simple topic. Study at home and it will be clear to you. Thank you so much.